Hi, so this is another new topic which SSC has been asking in its 2025 examination papers. And this is quite interesting. And this is a little off from the usual things that we study from SSC, which we study for the SSC examination. It is called Karl Pearson's coefficient of skewness. Skewness. Okay. What does the meaning of skew mean? What is the meaning of skew? Skew is basically the shifting of the normal. Okay, whenever we, let's assume we are having this particular data, I'll talk about the data which is mentioned over here. This is somewhere here in the center. Its mean, median and mode lie somewhere here in the center. Everything lies here. So because of some skewness in the data, or because of some sort of asymmetry in the data, there is a possibility that it will shift to the left hand side, right? And there is a possibility that it will shift to the right hand side. Okay, there is a possibility that it would have a right tail, and there is a possibility that it would have a left tail. So skewness is nothing but the degree, or the degree of shifting of data, and Karl Pearson's coefficient very efficiently tries to give us a small coefficient, which is a number which tells you how symmetrical or how asymmetrical. When I say how symmetrical, it means how well balanced the data is, or how asymmetrical, how imbalanced or unbalanced the data is. Okay. Whenever the coefficient is closer to zero, or if it is also equal to zero, that means the data is entirely balanced out and it is symmetrical. That means the people who are scoring low and the people who are scoring high are almost faring on the same side, or they are equal in number. Okay, or the impact is equal both from the lower side and both from the higher side. So it basically measures the impact of where the impact is going towards. Also talking about positively skewed data, whenever it is going above a positive one, first of all it is positive and it is also going above positive one, then we can say it is a positively skewed data, and the tail will move towards the right hand side and the graph will move towards the left hand side. We would see the spike more closer to the origin. Further, in negative skewness, whenever we have a negative sign and it is also above 1 or -1 and above, then we see, first of all, whenever we talk about a negatively skewed data, there is definitely going to be a minus sign. And whenever we talk about positive skewness, there is always going to be a positive sign. Okay, there is always going to be a positive sign. But when I talk about negative skewness, I mean to say that the data is shifting more towards the right hand side. The spike would be visible on the right hand side, and the tail would be visible on the left hand side. Okay, I'll show you a bit more about this on the next slide. See, what does it actually do? Karl Pearson's coefficient of skewness is a statistical measure that tells us about the asymmetry or skewness of a data distribution. A perfectly symmetrical distribution, like a normal distribution, has zero skewness. Karl Pearson's method quantifies the direction and extent of skewness in a dataset. Okay, I hope the concept is pretty much clear. The concept of Karl Pearson's coefficient is pretty much clear. Now I'll take you to the two formulas. If mean and mode have been mentioned, then you can use the formula mean minus mode whole upon standard deviation. If mode is not clearly defined, or if mode is not available in the data, then you have to follow 3 times mean minus median whole upon standard deviation. Whole upon standard deviation, right? Let's come back to the graphs that we were talking about. Talking about the most symmetrical graph that we have over here. This is basically called a symmetrical graph. Zero skewness is there because mean is almost equal to median is almost equal to mode. So this graph would look like a proper bell-shaped curve. See, this is looking like a bell-shaped curve, right? Also, the skewness is close to zero. That means things on the left hand side are almost being balanced out on the balanced out by the things on the right hand side. Further, Talking about positively skewed graphs, in positively skewed graphs, they are basically called right side skewed. When I say right side skewed, that means the tail is on the right hand side. Okay. Also talked about shifting. I also talked about shifting on the first slide, that the graph would look that as if it has shifted to the left hand side. So there is only one thing which you need to account for. You can only look towards the shifting, or you can look towards the tail. Okay. So I would recommend that you look towards the tail, where the tail is. Okay. So here in positively skewed data, the tail is towards the right hand side. Okay. Need not remember that the shifting is towards the left hand side. Remember only one concept. When you remember only one concept, that is when you don't get confused in the exam. Okay. Positive things are always lying on the positive side of the number line, right? Positive things are always lying on the right side of the number line. Similarly, a positively skewed data is always having its tail on the right hand side. All right. When do we call a graph a positively skewed graph? When the mean is greater than the median and the median is greater than the mode. Okay. So this relationship you have to remember. You have to learn this relationship. Tail is on the right hand side, long tail on the right, mean median mode is in this direction, and the skewness is called a positive skewness. Okay. The skewness is called a positive skewness. Similarly, in the negative skewness side, we are expecting that this is a left skewed graph and it is a negatively skewed graph. Similarly, you can see that the tail is occurring on the left hand side. The tail is occurring on the left hand side, and the mode is greater than the median and it is also greater than the mean. Okay, so this ends our theoretical part of Karl Pearson's coefficient of skewness. We will be solving two questions, and from that, it will be much more clear to you of how this Karl Pearson's coefficient of skewness works, right? So, there's one more small concept which I really don't want to miss out. Whenever we used the mode in this formula, we had a mode in the data. That is why it could be used. But in some data, there is a possibility that mode is not even available. Let's say the data 1, 2, 3, 4, and 5. Here, I can't say if 1 is the mode, or 2 is the mode, or 3 is the mode, or 4 or 5 is the mode. The reason is that none of them is occurring again. Okay. The definition of mode is that any data set, any given data set has a maximum occurrence. Okay. Has a maximum occurrence. But here, all of them have equal occurrences. That is why mode cannot be defined. And then people would say that if we already have the mean and we already have the median, why aren't we employing the formula that mode is equal to 3 median minus 2 mean? This is the standard empirical formula for calculating any of the three given quantities. If you have two quantities with you, you can find out the third quantity using this empirical formula. Why aren't we using the Karl Pearson's coefficient? Sorry, why aren't we using the formula for the empirical formula for finding out the mode? And why is there a very different formula as compared to the first formula? Both of them are following the skewness thing only. And when you have two things available with you, why shouldn't you find the third thing and use the first formula itself? There is a very standard reason for it. Okay, there is a very standard and universally accepted reason for it, and that explanation is given over here. Karl Pearson didn't typically use the empirical formula for the mode, which is 3 median minus 2 mean, because it is an approximation and not a true representation of the mode, especially when the data distribution is highly skewed or multimodal. Multimodal means that there are multiple modes. In this small data set of 1, 2, 3, 4, 5, all of them are modes. All of them are occurring once, so all of them have equal modality, right? All of them have equal modality. So the empirical formula is more useful for a quick estimate, for quick estimations when calculating the mode, directly is difficult, but it doesn't capture the true nature of the mode in all cases. Karl Pearson, a statistician, preferred to use methods that directly identified the mode from the data's frequency distribution whenever possible. Okay, we've also given you a piece of the brain of Karl Pearson of what he was actually thinking when he was formulating these formulas. Okay, when he was formulating these formulas. So, going forward, let's see. Now, we have a small question over here. We need to find out the Pearson's coefficient or the Karl Pearson's coefficient of skewness for the following data. What do we need for it? We don't have a mode with us. We don't have a mode with us. So we'll follow the formula of mean minus median. The entire thing done 3 times. Whole upon standard deviation. Let me quickly find out the mean. The sum of the 3 is 2 plus 9 plus 10, which is equal to 21. 21 over 3 is nothing but 7. So 7 is the mean. All of this situation is in the ascending order. So 9 becomes the central term, which is also equal to the median. So I have the mean, I have the median. I need to find out the standard deviation. We are going to find out the standard deviation against the mean only. Okay, when I have the mean as 7, so 7 minus 2 whole square, then 7 minus 9 whole square, and 7 minus 10 whole square. We'll first find out the variance and then go towards the standard deviation. 7 minus 2 is 5, so this is 25, and 7 minus 9 is 2, so this is 4. 7 minus 10 is 3, minus 3, or this 3 is equal to 9. 9 plus this is 13 plus 25 is 38. So 38 and 38 upon 3, this comes out to be my variance. This is going to be 12.66. This comes out to be my variance. Once I have the variance with me, the square root of variance is nothing but standard deviation. So the square root of 12.66 needs to be found out. The square root of 3 and 4, somewhere between 3 and 4. If I say 3.5, if I say 3.5, 3.5, the square of 35 is nothing but 1225. So a little more than this. So I should call it 3.6. That is a good approximation. That is a good approximation. Now I'll quickly use the formula. 3 times mean minus median. 3 times mean minus median. Mean minus median means 7 minus 9 whole upon 3.6. Okay. This is going to be 1.2 and minus 2. This minus should not be ignored because this is talking about a negative skewness. Okay. So this is 1 by 0.6 or 10 by 6 minus 10 by 6. So this comes out as 1.66, and that too of negative sign. So this is a negatively skewed graph. In a negatively skewed graph, we said that the tail would move towards the left hand side. The tail would move towards the left hand side. Let me quickly plot this graph for you so that the concept becomes very, very clear. Okay. We have the first value as 2. Let's assume this is 2. Then we have the second value as 9. And we have the third value as 10. If you plot a proper graph of it, you would see that the tail is here towards the left hand side. The tail is here towards the left hand side. So this proves our point. This proves our point that this is a negatively skewed graph. This is a negatively skewed graph, and the data set is higher towards the right hand side. Okay, need not remember this point where I say that the data set is rightwards. Just only remember that the tail is leftwards. Okay, so this is basically the real thing. This is basically the real deal. Okay, this is the real deal that we are actually going through right now. Okay, we'll do one more question, and I want you to practice along with me because this is a bigger question. Okay, this is a bigger question. Karl Pearson's coefficient of skewness for the following data. We need to first put it in the ascending order as well, right? So if I do that, I would get 10, 12. No, there is a small glitch. Okay, the small glitch is that let this not be 10, let this be 11. Okay, let this be 11. There is a very valid reason for it, because the sum of the entire series is going to be 199. And when you do a mean, when you follow up for a mean, at that time, this becomes a problem. Why? Because subtracting things from 19.9 is more difficult as compared to subtracting things from 20. So I'm bringing a small change to the data set, and I'll consider this to be 11. Okay, I'm cutting this out. So this is 11, 12, 14, 15, 18, 20, 22, 25, 28, and 35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So we have 10 data points. We have 10 data points available with us. Okay. Now these 10 data points are extremely critical. Why? Because now we are going to work this out. Let me quickly add it all up. Okay. This becomes 40, 50, 60. This is 100, and this is 140. This is 25. 140 plus 25 plus 35 is 60. So this all becomes 200. So 200 upon 10 data points would give me a mean of 20. So my mean is equal to 20. Okay. My mean is equal to 20. Now talking about the median. Here the total number of terms is 10, which is even. That means the fifth and the sixth. The fifth and the sixth upon 2 is going to be the median. So 20 plus 18 is nothing but 38, and 38 upon 2 is 19. So 19 comes out to be the median. 19 comes out to be the median, right? As I have mean, median with me, I now need to find out the standard deviation. Why are we doing it? We are doing it because in our second formula, 3 times mean minus median whole divided by standard deviation is going to be my output. Okay. Talking about standard deviation, right? I need to now find out the standard deviation. Standard deviation is found out against the mean only. So I'll quickly be doing it. 20 minus 11 is going to be 9, and 9 square is nothing but 81. I'll use a different pen color for this so that you remember what I have done. Okay, this is going to be 81, and this is going to be 64. 20 minus 14 is 6. 6 square is 36. 20 minus 5 is 20 minus 15 is 5. That is square is 25. 20 minus 18 is 2. 2 square is 4. 20 minus 20 is 0. 20 minus 2 is again 4. 20 minus 25 is 25 in terms of square. 20 minus 8 is 20 minus 28 is 8. 8 square is nothing but 64. And 20 minus 15, 20 minus 35 is 15. And 15 square is 225. I'm ultimately going to square the values. That is why I did not use, and I did not even say the word minus here. Okay. So I'll quickly solve it up. This is 250, 250 plus 100, 350, 350, 350 plus 85, 350 plus 85 is 435, 435 plus 25. Yeah. 435 plus 25 is 460, 460, and this is 469. Yeah. 469 plus 64. This comes out to be 13, 533. 533. Let me check if that's correct. Well, I just realized that there is a small correction. The 4 has been added thrice. It was supposed to be added 4 times, so I'll quietly do a minus 4 here, and my final answer is 529. Now this 529 has to be given another mean or has to be averaged out. So 529 upon 10 is nothing but 52.9. This is the value of my variance. Okay, this is my variance. So now once I have found out the variance, so 52.9 is the variance, I need to square root it down. Okay, for 52.9. So the square root of 52.9, 49 is the square of 7. So it's going to be somewhere very close to 7. And the next one is 8. So that's going to be 64. So very much less than 8 and a little more than 7. So I can assume it to be somewhere around 7.2. Okay, around 7.2. So 7.2 is the standard deviation. Quickly using the formula of mean minus median whole upon SD 3 times multiplied and done up. So 20 minus 19 is 1. 3 into 1 is 3. So 3 upon 7.2. 3 ones are 3. 3 24s are 72. The dot or the decimal will go and this will become 10 upon 24. And 24 fours are is 96. So 4.18. No, this is not 4.18. This is 0.418. Okay, 0.418. This is my Karl Pearson's coefficient. It is positively skewed, but very slightly positively. Okay, slightly positively skewed. This is slightly positively skewed. By looking at the data, if you have a little bit of a better sense of data, then you can actually see it. You can see it by how? By doing what? If you see the middle point or you see the median is somewhere here, lying here. Median is 19. It is dividing the data towards the left hand side and towards the right hand side. If you see the values on the right hand side, they are higher as compared to the values which are here on the left hand side, because the distance between 19 and 11 is hardly 8, and the distance between 19 and 35 is 16. Okay, so that is why you can also see that the data is more skewed towards the right hand side. So it is a positively skewed data, and the tail is going to be towards the right hand side. Okay, the tail is going to be towards the right hand side. Got it? Got it? I hope the entire experience is clear and you were able to deal with it. Okay, this is the same question. I thought that we would be needing some more space, so this is nothing but the same question. Okay, that's it. So thank you for being here, and I believe that you will be able to figure out all the theory questions of Karl Pearson's coefficient as well. Thank you.